Hi everyone. So I'm Pierangelo, and I'm going to spend the next 15 minutes to tell you about the future of 3D mapping and the difference we've announced today and yesterday at INTERGEO. We're really going to see how Gaussian splatting, something that you may have heard of, actually meets photogrammetry and how it improves the core of what surveyors need. Here's one example that has been really difficult in the past, and that's just one of them, that now is possible. Okay, here we'll have another example. That's a cell tower, but we'll zoom in a bit. And we see that even really complex structures look really natural. You can almost touch it. It looks real, it is real. And we're starting to see the blending between something that is reality and something that was a point cloud or something else. You can measure the reality. That's not a dream anymore. You can now measure reality. You have reality in your computer. And that's really changing the game. And we'll see all the different things that happen with that. That's another example. That's just a screen recording of our cloud. It's a large industrial complex, and well, it looks really realistic, and you can measure it, and it's geolocated. And yeah, that's what the Gaussian splatting model in Pix4D looks like. And that's in production. It's something that people can use in production. It has been tested, validated. It's not just a prototype or something like this. That's being used now. Now, okay. You're going to tell me, okay, it looks nice, well, but let's first start with actually who knows what the Gaussian splatting is. Does anyone know? Can we have a hand? Okay, at least 2 people, 5 maybe. Okay, 6. Okay, who has heard of Gaussian splatting before? A bit more, right? Okay. All right. So now, well, I'm going to just show a video which is going to explain it. Can you hear it in your?
Gaussian splatting is a novel technique for highly detailed 3D models with photorealistic rendering. Rather than a single algorithm, Gaussian splatting is a family of techniques that can prioritize speed, rendering quality, geometric accuracy, or other considerations. However, each method shares the same fundamental, primitive building block to construct its models, the 3D Gaussian. 3D Gaussians have 2 unique advantages over traditional 3D primitives, like the discrete 3D points that make up the point cloud. The first advantage is that thanks to their semi-transparent and gradually changing appearance, large numbers of Gaussians can be blended smoothly, making them ideal for high-quality rendering. This process involves projecting Gaussians onto the image plane and spreading, or splatting, their contribution across multiple pixels. The second advantage is that thanks to the mathematical properties of a 3-dimensional model made of Gaussians, we can precisely predict how changes in their parameters, position, scale, opacity, rotation, and color will affect the resulting renders. This lets us gradually adjust the Gaussian models so they match real-world photos when viewed from the right angle. Gaussian splatting's key benefit is its inherent ability to produce photorealistic real-time renders, optimized to look like the input images, and avoid traditional visualization defects like holes between point cloud points or artifacts in the triangle mesh. By leveraging the flexibility of Gaussians as a 3D modeling tool, this technique can model small geometrical details with a higher fidelity than traditional photogrammetry. With their position, scale, and rotation parameters, they can be arranged to represent complex and thin structures. At Pix4D, we combine the strengths of Gaussian splatting with the reliability and actionability of traditional photogrammetry outputs to generate an accurately scaled and georeferenced Gaussian splatting model, from which we produce both a point cloud and a mesh. As a result, both the generated point cloud and mesh benefit from Gaussian splatting's ability to reconstruct finer details. Gaussian splatting represents a change of paradigm, enabling the reconstruction of 3D scenes with an unprecedented level of visual quality. As research in this field rapidly advances, we can expect significant improvements in the near future.
All right. Now we all have some kind of understanding of what the Gaussian splatting means, what's the Gaussian splat, and we have already seen some sneak peek into what and how we apply it. We're going to go through how Pix4D is taking it further to really change the game in the surveying landscape. But before that, I just want to get some history out there. the first paper was actually invented or produced in 2023. So that's when the technology appeared. So it's quite recent, but it has been really fast. The pace is accelerating. New technology is coming, and while we are at the forefront there, we have already in February this year released something in production that people are using daily on our cloud. That was Gaussian splatting for Pix4D Catch, which is a phone scanner, basically. And at INTERGEO, we have released something on a larger scale for drones. And that's also available now. So that looks like this. So we have terrestrial acquisitions on the left, and now also larger scale models on the right with drones. Now, how is Pix4D actually taking it further? Pix4D really cares about accuracy, about the geometric fidelity of our results. And if you look at the right, we see on the lower scale, lower fidelity on the left, visual fidelity, and higher fidelity on the right. And then in the bottom, on the y-axis, the geometric fidelity. So actually, Pix4D should be on the top right, I realize now, where we want to have geometric fidelity at the highest, because surveyors really care about the accuracy and the fidelity. But actually today, what Gaussian splatting brings, that's why you have the two crosses there. You have the highest fidelity in the geometry and also in the visual aspect. So we actually combine both. Some people just do the pretty picture, some people just do accuracy. We can do both now, and that's still our first priority. And it's not just a gimmick, really, and I want to insist on this because we see some results out there that are just pretty and look nice, but that's also accurate, and we'll see a bit more later. So what it means is that you can measure it, you can overlay it with other designs, it's georeferenced, and you can load it and share it with people on the cloud. That's the thing, you can scale your processing, you can run multiple projects at the same time, you can share it, you have an unlimited amount of users who can access it, you can organize the access to the data, and so on. That's really what we do is Gaussian splatting for professionals. That's how I describe it. It's geometrically accurate and also visually pleasing. And here is something that we see, which is a derivative of the Gaussian splatting, and how that's actually where Gaussian splatting and photogrammetry meets. You see that photogrammetry actually does, you're used to point clouds in photogrammetry, but actually here, the Gaussian splatting that we've seen before, it also results in a more accurate, more dense and cleaner point cloud. And thanks to Robert Greenhall, who made this visualization, really we've seen that even difficult geometries, and maybe I'll play it again if I manage. Here we go. So that was the previous point cloud, and now if you look at it, you see it's much denser, much cleaner on the edges, and even small details are well reconstructed. That was a drone capture, and that maybe is a phone one. But the result of this is a cleaner point cloud, but also due to this a better mesh, a better orthomosaic, better digital surface model. And if you look on the next slide, we see that actually on the left, that's something that's really difficult. That's kind of reflective, it's homogeneous. I mean, that's a difficult surface, right? And this was not edited. That's how it came out. Nothing of what I show you was edited manually. Like that's how it comes out. And you see how sharp it is, how clean it is, and even on tricky surfaces. So that's really a game changer. And you can measure it. And then on the right, you have a larger area. But overall, really, it is a game changer. We've been discussing it these 3 days. There have been a lot of optimizations of existing algorithms and so on, but we really believe that this is a step function. That's an upgrade that is really happening every 10 years, maybe. So, and that's happening. We're still at the beginning. You've seen it's only 2 years, but it's really fast. We're still going full speed at it, and it's really only the beginning, but it's already amazing. Here is just to show you, that's again a screen recording of a rather large model that's on our cloud, and you see that we also managed to not only have the best results, but also the viewer is super reactive. You can work with it. It's not cumbersome. It's actually easy to use. We really care about the ease of use, so that we can actually deliver, we can be efficient, and we can implement this in our real daily workflows. And I was talking about accuracy. Now you've seen it's pretty, but now that's accuracy. We take this really seriously. We have test fields with references, and that's now a terrestrial scan with the phone. You see that there are lots of checkpoints there, so there is no ground control point. That's all checkpoints. And what it gives is that we have, and of course it was taken with the phone with an RTK antenna, but we have between 1 and 3 centimeters on the absolute accuracy. And then we'll see on the next slide, if you want to measure it, there should be some small animation. You can measure it, and it's spot on the measurement. So it's below the centimeter in relative accuracy in this case. So we can really see that it's not just beautiful; it's also accurate. And I mean, it's kind of a dream that you can measure on something that you can actually recognize, you can see it, no more guesswork, you can actually measure as if you were on site. What else is a highlight? We are also ISO certified. That means we have the highest standards of security. We take this really seriously so that we can scale the usage even in larger companies. The data fidelity, as we've been discussing, is really important to us, the accuracy, and then of course, well, you want to be able to show this data to decision makers. We have an easy way to share it. Think just about how easy it will become to explain to decision makers or to your clients, look, we are actually doing a good job. It's not just a point cloud or something, you're actually showing like it was real to your clients, and it's going to be easier for them to understand as well sometimes in certain cases, and so it's also good for business in this sense. So what's next, right? That's the next question. Well, first of all, I'd like to just think about why it's a game changer, what kind of opportunities it's opening. Well, we've kind of touched on them, but I'd like to repeat them. So first of all, you have a realistic model for decision makers. That's key because it's going to fasten up, make it faster to take decisions on key projects. You can implement the technology better, just because it's easier to understand for all the higher ups and everyone. The second one is actually, and that's not neglectable, it is a step up in the fidelity and the accuracy of the data that a surveyor can get. With your phone, with drones, it is a game changer, really. It's as I said, it's a step function. It's a higher up, less time cleaning the point cloud, more details, even where before you couldn't have any data. And then the third one, well, now that it's so realistic but still accurate, well, okay, decision makers like it, but anyone else would also like it, I think, right? What can we invent? Where can we go with such data? I'm really convinced that we can open up and make geospatial work even broader, that we can give access to this kind of data to more people, and that the surveyors at the heart of this can really, again, have a new wave of type of work and broader work. And let's see what's happening. Maybe you're going to sell your house with such a model. It's already happening, actually. Okay, for us, I've been mentioning that we have it on our cloud. We're also going to have it on our desktop. That's the next priority. It's coming in the next couple of months. And we're, of course, going to keep improving, keep pushing the limits of the speed, but also the quality. And also, of course, we always keep in mind that the first priority is accuracy. That's it for me. And yeah, thank you. If you have any questions, I'm here. And we're still at the booth for another hour or so. Yeah, thank you.